Problem number 2. If the numerator of a fraction is selected from this set, 1, 3, 5, 7, 9, and the denominator of the fraction is selected from this set, 2, 3, 4, 5, 6, 7, what is the probability that the resulting fraction can be written as a terminating decimal? Alright, well, let's just take a look at some of the cases. Now, whether it turns out to be terminating decimal or not is going to depend on the denominator, alright? And the denominator is going to be one of these values. Alright, so, any number divided by 2 is going to be a terminating decimal. If it's even, it'll divide evenly, and if it's odd, the fractional part will just be a half, right? So, these are all odd numbers, so they'll all give a terminating decimal for 2. I'm going to skip 3 briefly, but basically for 4 and 5, we can also argue the same thing. Anything divided by 4 is going to have a terminating decimal, and anything divided by 5 is going to have a terminating decimal. Because if you look at 1/4, that's 0.25. That's terminating, and anything, essentially you're taking 1/4 times something. If I take a numerator over a denominator, that's the same thing as the numerator times the reciprocal of the denominator. Okay, so if we just look at the reciprocals of these, that should tell us which ones of these will give us a terminating decimal possibility. All right, so 2 and 4 and 5 are always going to give us terminating decimals. If we look at 3, 6, and 7, though, for some of these cases, you get a terminating decimal, and sometimes you don't. Okay, so if you divide 3 by 3, obviously that's 1. So that's a terminating decimal. But if you divide 1 by 3, you get 0.333333. Okay, same thing. 5 divided by 3, you get a number that repeats, so you don't get a terminating decimal, or 7 by 3. But if you divide 9 by 3, you get 3, which is a terminating decimal. Okay, so let me back up a little bit here. In order to calculate the probability, we want to find probability. We want to find the number of desired outcomes. Okay, and divide it by the total number of possible outcomes. Okay, of outcomes. Alright. And the denominator here of the probability problem is fairly easy to figure out, because we have 5 choices for the numerator and we have 6 choices for the denominator. Okay, and so we're just going to have 5 times 6 equals 30 total permutations of numerator and denominator from these two sets. Okay, so the denominator here of the probability is 30. Okay, so now we want to find out how many of all those possible combinations, how many of them can be written in as a terminating decimal. And I'm actually going to use something called complementary counting. Complementary counting. And that is to count the thing that we don't want, the undesired outcomes. With the outcomes that we don't want to count are the ones where you get a repeating decimal. Okay, so the complement of the ones, so that whenever you create a fraction out of these two sets, numerator over denominator, you're either going to get a terminating decimal or you're not going to get a terminating decimal. Okay, and the sum of all those fractions, the ones that terminate and the ones that don't terminate, are going to be the total permutations, right? So they're either going to terminate or they're not. So if we want to count the thing that we don't want, which we're looking for the ones that give us a terminating decimal. Let's count instead the ones that give us a repeating decimal. Alright. Decimal. And what I'm going to do is I'm going to do some casework. Okay, so let's look at case 1, where the denominator is 3. Okay, because we know we're only going to get repeating decimals when we have 3, 6, or 7 in the denominator. All right, so let's look at those cases. First of all, when the denominator is 3, then the numerators that give us repeating decimals are what? 1. 3 over 3 is 1, so that's not. 5 and 7, and 9 over 3 is 3. So we have 3 possible cases there. Okay, so that's case 1. Let's look at another case. The next case would be case 2, where the denominator is what? The next one that's going to give us a repeating decimal is 6. Okay. All right. So if we look at the numerators, 1/6 is a repeating decimal, right? 3/6, that's just a half, so that's not repeating. 5/6, that's repeating, and 7/6, that's a repeating. And if we divide 9 by 6, the 3's cancel, right? So we end up with 3 halves, which is 1.5, and that's not repeating. Okay, so again we have 3 possible outcomes, 3 possible combinations that give us repeating decimals. Okay, and then let's look at the next case. Case 3, let's take the denominator is equal to 7. All right. So the possible numerators would be 1, or 3, or 5, or 9. So we actually have 4. Alright, so those are all of our cases. Okay, we know we're going to get terminating decimals when we have a denominator of 2, 4, or 5, and 3 is going to give us a repeating decimal in 3 cases. 6 is going to give us a repeating decimal in 3 cases, and 7 is going to give us a repeating decimal in 4 cases. So, what? We have a total of 10 cases that give us a repeating decimal. Okay? But what we want to know is how many of these fractions will result in a terminating decimal. So remember that they're either going to be repeating or they're going to be terminating. Okay, so if we had 10 that have a repeating decimal and we had 30 total, then the total that of the desired outcomes is going to be 20. Okay, so 20 combinations of numerator and denominator are going to give us a terminating decimal, and that's out of 30 total. Okay, you see that? So 10 are repeating, that means 20 had to be terminating. And that gives us a probability of 2/3. Okay? So, hey, that's a repeating decimal. That's like 66.7%. Alright? So that's our answer. The probability is 2/3, or about 66.7, or 66.6 with a bar over it. Maybe I should have written it like that. That's a repeating decimal. So about 66.7 or 67% are going to be terminating decimals. So there you go.